Dear colleagues, we will start in 5 minutes. Now we are waiting for the other members who will join us in the section number 2. Yeah. Good day, dear colleagues. We will start our section within the fifth CIS conference, which is called IT Applied in Education and Research. And our first speaker, with a paper titled Landmark Detection Using Convolutional Neural Networks. And I'd like to notify you that the total amount of time you have for your presentation is 10 minutes in total, 7 for your presentation itself, and 3 for the questions. So please, if we have some presenters on this paper, please, you may start. But as I see, there is no members of this research team. So I think we're gonna switch it. Who may begin right now because almost all of the researchers are joining us online. So we'll begin with the volunteer.
Hello, dear colleagues. We can be a volunteer. We can be the first one
Draw and
for presentation.
your paper. Could you please?
1 second. I can share, yeah, the screen.
Okay, yeah, sure.
Yeah. Please tell me, can you see my screen?
There we go. Thank you.
Yeah. So, good afternoon, everyone, my colleagues there. I am Berdikhin Dmitro, and from Taras Shevchenko National University of Kiev. And with my colleague Vadim Zuzun, we presented our project titled Development of the Information Structure of the Project for Creating a Web Platform to Improve the Ecological Culture of the Population. Next screen. So, our world faces critical ecological challenges: climate change, pollution, biodiversity loss, and land degradation. In Ukraine, over 17% of citizens acknowledge climate change as a serious threat. Yet, only about 25% engage in sustainable behaviors. And this disconnect is alarming. To address it, we propose a digital solution, some web platforms that not only informs, but also actively involves users in conscious activities. Web platforms are uniquely positioned to educate and inspire change. They allow for scalable interactive communication, which is essential in environmental education. So our platform will include interactive courses, news, forums, gamification with rewards and leaderboards, and integration with social media. This feature promotes sustainable think and active participations, and we think it's helped build a culture of responsible consumption through collective actions. Despite digital progress, current approaches to environmental education remain limited. First, educational gaps persist. Only 20% of Ukrainian schools promote eco-awareness, and fewer than 10% of students study environmental science in depth. Second, access issues. Rural areas often suffer from limited internet connectivity, which restricts access to crucial digital content. And third, the most platforms rely on general analytics tools like Google Analytics, while useful for tracking visits and clicks, they miss context-specific econometrics, such as user behavior change, engagement in environmental actions, or long-term knowledge retention. Um, Let me briefly introduce the system architecture of our platform. Our platform named is GridWave, and it structures into 6 main modules: user interface, content management, security, database, analytics, and marketing and social media. There you can see the mathematical models that we developed. The first one is utility coefficient, evaluates sum of key indicators like visitors, session time, and interaction. The second one is user engagement, the ratio of active users to total registered users. And the third one is content effectiveness, the average number of interaction per content item. So in let's see some. Yes. So let's see some cases from these mathematical models. The first one is user engagement analysis. And in these cases, we analyzed engagement levels during different months. September showed the highest engagement rate at 0.636 compared to 0.6 in July. Why? Maybe because in September we launched a gamified recycling campaign supported by social media outreach, and this clearly demonstrates how targeted content and strategic timing increase engagement. The second case is content effectiveness. Here we evaluated content effectiveness. In November, we achieved the highest score, 122 interactions per content unit compared to 116 in September. This shows the impact of personalized and interactive content and proves that regularly updating and optimizing materials is essential for keeping users engaged. And the general result of model application, on this slide, you can see the summarized results from 5 months of platform activity. And in September, had the highest utility coefficient, driven by high user numbers and interactions. And July had the lowest, likely due to summer holidays. So the results confirm that seasonal trends, content quality, and marketing campaigns directly influence platform performance, and our models provide actionable insights to adapt the platform dynamically. And conclusions. In conclusion, our research shows that conceptual and mathematical modeling are vital for developing efficient interactive educational platforms. And our Green Wave system proves that combining content, design, and tailored analytics leads to measurable improvements in user engagement and environmental awarenesses. And our future plans include expanding our analysis over a full year, incorporating user feedback, implementing machine learning, new features, new metrics. So yeah, we have a lot of planning and a lot of ambitions on this web platform. Thank you for your attention, colleagues.
Thanks a lot, Victor. Any questions for the presentation? Okay, really nice project actually, as the ECA initiative are really relevant up to our modern society and like general future for the whole planet, not only certain regions. And actually, I do have a question for you. Do you plan to apply the math model not only for evaluation of users involved within the platform, but also to support the decision making for future development of your platform?
Yes, of course, of course. It's data, and this data should be useful for future development, future decision-making program sums. I think, yeah, of course.
Really great. So thank you for your presentation. And dear colleagues, my bad, I forgot to say you that it would be great if you would turn the webcams on. Yeah, it's great. We really see you. Hi. So yeah, really appreciate your presentation. Really nice and relevant topics. So good luck, and hope that in the future you will have as much users as possible. Thanks a lot.
Thank you very much.
Yeah.
Thank you very much. Have a nice day, colleagues. Yeah.
Thank you so much. Yeah. So, and our next presenter, who is present here in the Zoom meeting, is the paper with the D number 94 with the title Improving Student Speaking Skills with Flipgrid, a tech-driven approach. These authors are from the International Information Technology University, and I see that here we do have Nazim. Nazim, could you please?
Hello, can you hear me?
Yeah, sure. And could you please turn on your webcam for us to see you here?
318, да, вот он. Is it visible?
It's still loading. Yeah, and could you please turn your webcam to show your face and for us. Yeah, it's great. Thank you. So have your time.
Good afternoon, everyone. Can you hear me? Okay, my name is Nazım Bolatkazi, based by Nazım Bolatkazi, and I'm pleased to represent the International IT University from Almaty, Kazakhstan. Today, I'll be presenting our research titled Improving Student Speaking Skills with Flipgrid. We conducted in collaboration with my colleagues, Aysel Kaldarova and Marco Vasquez. This study was carried out as part of our ongoing efforts to enhance language learning as an educational technology. And we are excited to share our insights with you here at the 2025 International Conference in Istanbul. Let's start. Here we go. As we all know, speaking is one of the most essential skills for success in both academic and professional settings. However, many language learners face persistent challenges such as low fluency, lack of confidence, and limited opportunities for feedback, especially in traditional classroom environment. This is where digital tools like Flipgrid come in. And Flipgrid is a video-based platform that offers students an engaging and flexible space to practice speaking. And here we go. Let's take a closer look at why Flipgrid was chosen for this study. And what makes it especially effective is that it encourages self-expression, helps build speaking confidence, and supports multimodal feedback through video replies, text comments, and even emojis. It also enables personalized learning. Students can re-record their response, reflect on their performance, and learn from their videos. And speaking is widely recognized as a key skill in language learning. According to Richards, it plays a central role in real-world communication, as well as in academic and professional success. And however, traditional teaching has focused on reading, writing with limited opportunities for speaking practice. Students may receive little personalized feedback, and many experience anxiety when speaking in front of others. And specifically, Flipgrid stands out for its synchronous video response, which can help reduce speaking anxiety. It also promotes peer interaction, building a sense of community and engagement, which is especially valuable in language learning. Here we go with the next slide. Building on previous research, Flipgrid has shown clear benefits in language learning. Studies like Gleason and Bundle can enhance fluency, improve pronunciation, and increase the quality of feedback through multimodal responses, text, video, or emojis. Despite these challenges, the central hypothesis of this study is that Flipgrid can significantly improve students' fluency, accuracy, and confidence in speaking when compared to traditional instruction. To examine the impact of Flipgrid, we used quantitative research design involving 120 first-year EFL students at IATU who were at the intermediate level. The participants were divided into two groups: experimental groups, 60 students, and the control group consists of also 60 students, like traditional methods such as group discussions and oral presentations in class. And all students studied similar academic topics like higher education, globalization, and soft skills, ensuring alignment with their syllabus. And to evaluate this progress, we conducted pre and post tests that measured three key speaking aspects like fluency, accuracy, and confidence. These metrics provided a clear comparison between the two instructional methods. Let's see it here. To assess students' speaking performance, we use three clear evaluation criteria, as you see from the table, yeah? Fluency, accuracy, and confidence. And each criterion was measured using a rubric scale from 1 to 5. And as for the tools, Flipgrid was used for synchronous video tasks and feedback. And Microsoft Teams helped with video sharing, and all activities required students to use internet-enabled personal devices for access and for them. Here we go on with the results. Results clearly show a significant improvement in the speaking skills of students who use Flipgrid. In terms of fluency, you can see from the table, experimental group 3 made the most progress, improving from 2.9 to 3.9. And for accuracy, group 2 stood out, increasing from 3.9 to 4.5. And in confidence, group 4 had the biggest gain from 3.5 to 3.9. And in contrast, control groups showed only modest gains without the benefit of self-paced practice and individual feedback. Their progress was more limited. Let's see. And here we go on with the conclusion, limitation, and requirements. And to conclude, this study confirms that Flipgrid is an effective tool for improving students' fluency, accuracy, and speaking confidence. It features promote an inclusive and student-centered approach, aligning well with today's push for digital and interactive classroom. However, there were some limitations. The research was conducted at a single institution and over just one semester, with the focus only on speaking. Also, access to reliable internet and devices may have affected participation. And we can say that Flipgrid has the potential to transform speaking instruction and support more dynamic, modern language learning environments. And thank you very much for your attention. I hope this presentation provided valuable insights into how Flipgrid can be used to enhance students' speaking skills and confidence in language learning. And once again, thank you for the opportunity to share our research at this international conference in Astana.
Thanks a lot, Nazim. It was really nice and interesting research. And I think that all of us really happy that modern tools, information technology provide people and users with great tools to train yourself in different areas. And I think that this tool is really nice because one of the most problematic area of skills within the new language learning is especially speaking. It's really nice that you have shared your experience and did the nice analysis of the results. And maybe some of the members of our auditorium have a question. Okay. I have a question for you. How do you evaluate the integration of such tools as ChatGPT or Gemini or independent self-learning of the language? And have you practiced it yourself? Thank you.
Can you repeat the part, please? I couldn't.
Sure. How do you evaluate the integration of different AI models for the self-learning, self-taught courses of new languages, learning by some people, and have you experienced it yourself?
Yeah, last periods we are it's very popular now. We try to use this kind of methods, and we're always welcome to try and experience this kind of AI methods.
And I think that we have the next presenter who is also here. And actually, I found out that we have the speaker with the ID number 77, who is here with us, is Dina Kuryagin. Could you please share the presentation with us? And also, it would be great if you could turn your webcam for us to see you delivering your presentation. Yeah, it's great. Thanks.
Are you hearing me? Yes.
But so we still don't see your presentation. What to say?
So I want to share. Okay.
Sorry. We are trying in the queue format as in the beginning of the meeting. We didn't have all the people by the order for things like with this program. What's the number of your ID?
Just interested to.
No.
Did we finish with ID 17, for example?
We did ID number 80.
18?
Yeah, 1894. And now we're gonna have the paper with ID number 77.
Okay.
Yeah.
Thank you.
So are you see my presentation? Yes, my screen.
Very good, thanks.
It's okay. Okay. So good afternoon, dear colleagues and the participants of the conference. So my name is Dina Kuryagin. I'm the master student of International IT University. So today I will present our research titled Analysis of Virtualization Technologies to Optimize the Use of Hardware in Data Centers. So the relevance of the work that the virtualization has become a fundamental part of modern IT infrastructure. It helps organizations scale systems efficiently, reduce hardware costs, and optimize resource usage. So today, virtual machines are used everywhere, from universities and laboratories to large corporate data centers. Among many available platforms like Microsoft Hyper-V and Oracle VM VirtualBox are especially popular. So while they offer similar functionalities, their performance and efficiency under load can vary significantly. This make their comparative analysis highly relevant. Especially in environments with limited computing resources and data centers were directed to optimize the work of hardwares. So our goals was to determine which hypervisor performs better under typical CPU load conditions. So in our literature review, we found a wide range of methods aimed at improving virtualization efficiency. This include the meta-heuristic algorithms like gray wolf optimization and genetic algorithms for energy efficient VM scheduling, and machine learning models such as random forest used to predict workload and optimize placement. and hybrid strategies like conditional random files-based MOS algorithms and improved line optimization that balance multiple factors, energy, CPU load, security, and execution time. So the current research shows a trend toward intelligent, adaptive, and multi-objective frameworks for managing virtualized environments. So the methods and the materials for this one, we selected two widely used virtualization platforms from Microsoft is Hyper-V, and the cross-platform hypervisor is Oracle VM VirtualBox. So on the both systems, we created virtual machines with identical specifications. It was like guest operation system. It was Ubuntu the version 22, and with 4 virtual CPUs and 2 gigabytes of RAM. And to measure CPU performance, we used performance monitor on Hyper-V and activity panel on VirtualBox. We run each virtual machines for 30 minutes and normal operating conditions, and recorded CPU usage over time. And to analyze and compare results, we visualize the data using Python and with the matplotlib library. So from the results in this slide, we can see the graphs. The first in the left side, the graphs which we take from a performance monitor on it was which running it was a virtual machine which running on Hyper-V, and at the bottom one, the graph of the virtual machine it was a CPU loads of virtual machine which running at the virtual Oracle VM VirtualBox. So at the right of the slide, we can see the graphs. It's the final comparison graph that was written in Python. So the performance graph clearly show that Hyper-V consistently maintained low CPU usage, mostly under 15%, with only minor spikes. Despite the Oracle VM VirtualBox showed higher and more fluctuating CPU usage with frequent peaks above 30%. This suggests that VirtualBox generates more overheat and manages resources less efficiently. And from these results, we conclude that Hyper-V is better optimized for managing workloads, especially when system stability and CPU efficiency are critical. So the discussion, this side, we can say that from these results, this difference can be explained by the fact that Hyper-V is a native type 1 hypervisor with deep integration into Windows, is built for enterprise level performance. Its architecture reduces overheat and improves workload isolation. In contrast, VirtualBox is a second type of hypervisor that runs on the top of a host operating system. While it's user-friendly and cross-platform, it introduces more overheat, especially under loads. And then These findings are consistent with other studies that highlight the performance advantage of native hypervisor like Hyper-V. Still, VirtualBox remains a great tool for education, software testing, and small-scale projects due to its simplicity. So for future research, we plan to analyze the expand testing to include RAM, disk input output, and other metrics, and compare with additional hypervisor, maybe like VMware workstations. So to conclude my presentation, I would say that research came to results that Hyper-V is recommended for corporate data centers and high-performance environments, offering stable and efficient CPU usage. Oracle VM VirtualBox, despite its limitations, is well suited for smaller projects and educational use. So thank you for your attention.
I think it was really nice research and as well relevant for us as like the trends in artificial intelligence, which is for sure requires as much computational efficiency as possible. And I think that the cloud technologies and possibilities to improve the performance from the backside is really great and interesting and of course important. And maybe some visitors in the audience have questions for you. Any questions? Yeah, we do have a question.
Thank you, Dina. One question. You have stated the aim of your work, but what specific objectives do you plan to address in your research?
Sorry, can you explain the question?
Могу рассказать, да, если хотите. То есть вы сейчас рассказали о возможности, да, производительности гипервизоров, да, а какие задачи именно конкретно вы хотите решать в своих исследованиях? Вы сейчас, в принципе, цель ваша была рассказать нам о существующих. А в чем, как бы, вы сами, где планируете, какие задачи планируете решать с помощью этих вот представленных моделей?
Okay, I understand. So I want to, with this hypervisor, I want to help to data centers, maybe at Kazakhstan, to be optimize the work of hardwares at data centers. And the main goal was to recommend for data centers which hypervisor are good and which hypervisor are efficient for resources of data centers. So it was the main goal.
Martina, so we may continue our section. And our next presenter who is with us is Ayhanbek, I think. Ayhanbek, are you with us? Do you hear us?
Yes, but I have a question.
What?
I have a question. So my QE is beginning at 16:20. Is it okay for me to present now?
Yeah, for sure. Yeah, you may begin because the queue has changed a bit. So if you are ready, you may begin right now. There is no any problem.
Yeah, great. So I can share my screen.
Yeah, sure. Yeah. Everything's fine. You may start. Thanks.
So can you see my screen?
I do.
Guys, can you see my screen?
I do.
Yes. Yes.
Okay. So Good day, everyone. My name is Yak Fayambek, and my research topic is analytical model for developing education programs considering Kazakh IT labor demands and student performance prediction. So, as you may know, with the global demand for IT professionals, skilled professionals, universities, and educational institutions ensure that their program equips students with relevant skills, with key skills and competencies from labor market. And however, universities try to align their education with labor markets and students' needs. So our site aims to address this challenge by integrating labor market and student performance data into this curriculum design process. So the two research questions. So how can the integration of job market analysis and student performance prediction enhance the alignment of IT education programs with industry needs in Kazakhstan? And what role does the AI, specifically LLM, play in identifying key competencies from job advertisements and predicting student performance? So we have researched similar studies around the labor market, around curriculum development, and we have concluded that studies have shown that AI can significantly enhance education by personalizing learning experience, that NLP could help to analyze job market data, that later in these recent days, generative AI is keeping its track, and it allows for automated creation of personalized learning content. But also with these such wonderful benefits, we can see challenges such as, I think, as the greetings guests from Poland have said that there is challenges such as bias in data, privacy concerns, and ethical dilemmas as well. And there is also one section which emphasized on human AI collaboration. So it suggests to collaborate focus on human AI collaboration, also work with crowdsourcing from so what we did, models that we used is fine-tuned LLM, large language model, and we have used multiple machine learning classifiers with clusterings. So for fine-tuned large language model, we have used Skillspan dataset, open source Skillspan dataset, and for analyzing labor market, we have used job postings from major Kazakh platforms such as Headhunter, EMP-KZ, and for analyzing student performance data, we have used open source Kaggle dataset, which encompasses academic, demographic, and socio-economic variables. It was around 34 columns. The next is, first of all, we'll talk about skill extraction model that was trained on fine-tuned on Llama version 3 with low rank adaptation technique. LoRa, in short, it enhances models' capacity to learn without substantially increasing the number of parameters. So it was easy to maintain. The reason that I chose Llama 3 over GPT because it was open weight, free to control, so it was free to use. So there is nothing like I wouldn't pay GPT for API to use. So that was one huge advantage over GPT. And I have used for bit quantization. It was used to reduce memory usage because I'm using Google Colab, which is a free version, so it couldn't handle massive information, so that's why I use quantization. And the next thing that I have used gradient to manage large datasets and computational restrictions. So batch size management and gradient accumulation were employed so to work with such massive information. But you can see here that it had its own problems. For example, our fine-tuned LLM didn't find rare skills. It couldn't identify rare skills from job descriptions, so that was one drawback. But nevertheless, skill extraction approach, comparing with other methods, you can see it on the table, it has surpassed existing models. So in skill span dataset specifically, in skill, it has achieved 76.2%, while in knowledge field, it has achieved 79%. In total, we can get that it's 77.6%. So based on the analysis, based on the skill extraction, I have created two software developer, two curriculum design for software developer and system administrator. So you can see that mostly in Kazakhstan, for software developer, it asks for Java language, Java programming language, but we can see a rising trend for Python as well. Also, for software developer, it asks for web development, HTML, CSS, JavaScript, but also we can see a rise of React, Vue, JS, etc. Database management, PostgreSQL, and version control and deployment, which is Git and DevOps. For sysadmin, for example, we can see it's operating system, huge, massively. It's like monopoly for operating systems, but yes, there exists Microsoft and networking, server management and visualization, network security, monitoring and automation tools. So the next thing that we did is analyze student performance data. So here you can see we have used several models, and the most highest accuracy rate is having logistic regression, random forest classifier, and CS. So yeah, while in the next image we can see feature importance on graduation. So feature importance which is higher than 0.5. So the most influential feature for graduation, it was curriculum units second semester. So the courses that you chose for you in the second semester is the most important factor for your graduation. So we can see that additionally, macroeconomic indicators such as unemployment and your father, mother's occupation also contribute to the graduation outcomes as well. Also, we can see that application mode, age at enrollment also plays a role in certain performance on graduation. So I have given several strategic recommendations for educational institutions. So first of all, predictive analytics should be used to identify students who are at risk. So underperforming early in the semester is, we can see that in the second semester, it's the highest factor of graduation. So it should be important. The next thing is that holistic support, that institutions should implement support system like combining academic advising, flexible learning option, also including peer mentoring as well. and continuous improvement. So curriculum should be continuously refined. So based on this labor markets data, student performance data, so that it will align with the real world. So to conclude, this study presents data-driven approach to IT curriculum development. We have used LLM to identify key skills and competencies from labor market, and using this data, using students' performance data, we have created model to use for education institutions and universities.
Thanks for your great research actually, because you have applied many models of like modern languages within machine learning, and it's really interesting as our government have said and installed the direction of future preparation of students within the IT, and our president said that we have to prepare about 100,000 people, students who will be the IT specialists, and it's really interesting. You have studied this area, and that people may use your tool to define in what direction they should go, and also that it's really useful for the educational institutions who may understand what the labor market will be in the future. It's really relevant and interesting for us, especially as like IT educators. So yeah, it's really interesting. Thanks for your presentation. And maybe some people from the audience have a question. No question? Yeah, there is a question for you.
Thank you for the insightful presentation. The topics addressed are highly relevant. My question, how do you envision the practical application of your research findings?
Could you repeat, please? Could you repeat?
How do you envision the practical application of your research findings?
Okay. So I'm actually creating something massive. So it's going to be one small microservice. So right now I'm actually creating human AI assisted collaboration, obviously platform for professors, for curriculum developers to use. So I'm going to include this labor demand analysis in this platform. So it's going to be in a real world application.
Thank you.
Thank you so much. And actually, I do have a question for you. And the question is it possible to integrate or maybe modernize your system to predict the future demand? For example, to prepare students in next 5 years, we have to change the syllabus for now. And as the educational institutions sometimes have a lot of bureaucracy at the organization process. So is it possible to create the system using your average to predict our future plans, for example, based on the current demand or like 10 years maybe to prepare students for the future? Yes.
I think yes, since we are tracking real world hiring platforms as Headhunter and EMBKZ. So from this, we are already like fetching job descriptions and we are retrieving relevant skills. And based on these relevant skills, we could predict future skills that will be needed, and those skills that will be like dead.
Thanks a lot. It's really nice. And yeah,
also, I want to thank you for your for opportunity to present here.
Thanks a lot, and good luck for your research, and hope that you're gonna like implement the system and integrate it within the modern government systems for final users. Yeah, thanks a lot. And we have the next presenter with the title, with the paper title, Methods for Forming Project Groups for Collaborative Scientific Activity based on the Analysis of Publication Elements. And our speaker is Saltanat Sharipova. Yeah, could you please share your presentation? Yeah, hi.
Hello.
We hear you. Do you hear us?
Yes. Could Yerkejan share my presentation, please?
Okay, we got it.
Thank you. Okay, thank you. Can I start?
Yeah, sure, you may start.
Good morning or good afternoon. My name is Saltanat Sharipova, and the title of research is Method for Forming Project Groups for Collaborative Scientific Activity based on the Analysis of Publication Elements. The next slide, please. And the aim of our research is to optimize research group formation, and research tasks analyze the structure and content of scientific publications to extract key elements, for example, authors, institutions, key important topic. Mechanism to evaluate the contribution of individual publications and authors, and validate the method through pilot implementation in multiple universities and measure effectiveness. And the last forecast scientific activity trends using time series models. And the next slide, please. In general, a scientific project group is a research team focused on solving problems within the area of some research topic. And the publications belonging to this group is involved into the process of extracting key information from its content. And so we have, first we have raw text, which becomes a structured element, which is suitable for further analysis. On this slide, you can see the process of extracting key information from the content of scientific publication. First of all, document is uploaded, then it is parsed, and then we have such elements like scientific academic institution, topic, author, and keywords. And in general, we can say that we analyze these publications, and then the content of these publications we do from this like semantic network, and we show this semantic network as a graph. And in this graph, nodes are objects or entities, and the arcs of this graph are connections, which means a relationship between these entities. So the next slide, please. Here you can see the thesaurus. Thesaurus is the result of building semantic network. For example, this thesaurus links semantic features of information and the ability of user to perceive the information, because when somebody sends some information to another person, for example, two of them can understand this information according based on his knowledge, the amount of his knowledge. That's why we use thesaurus. So here we used an algorithm of forming database of publication characteristics. The first one we split text to sentences and words, and then a pattern of short words. For example, words which have less than 3 characters, we exclude them. Then we delete stop words. After this, we form a general list of words. And then we do stemming, and we count frequency of words or sentences in our content. And after this, we identify authors and organizations. The next slide, please. So after at this slide, you can see results of clustering publications by thematic groups. For example, you can see here main topics, 3 main topics, and the number of publications and keyword examples. The next slide, please. Here, after clustering, we have such graph. Yes, here you can see the clusters, 3 clusters. The dots on the diagram indicate individual scientific publications projected into the 2-dimensional feature space. The color of the dots corresponds to the clusters, for example, scientific group, to which the publication is assigned. And each group brings together publications with similar topics and participants in identifying potential scientific communities for cooperation. Here we used key nearest neighbors, this method of clustering. And the next slide, please. After doing clustering, we tried to predict the success of community formation. For this purpose, we used ARIMA model, it is a forecasting model. And scientific indicators was annual number of publications and citation index. After doing this forecasting, we do some measurements to assess the success of our forecasting. So the accuracy of prediction was 89%. And the time for forecasting, we do the comparison with general methods, and it was 35% decreased, which is a very good result, I think. So the next slide. So we think that the task of our research was achieved, and thank you for your attention. If you have any questions.
It's a lot for presentation.
Can I ask a question, please?
All right, please. Yes.
Thank you for your presentation. It was very interesting. Can you tell me what are your plans for the future? Well, according to this research.
Thank you for your question. I forget to say that we do pilot implementation of this project into 3 universities. This research was made within the framework of scientific project. So we implemented it into 3 universities, and our plans are to broaden the geography of it and to implement it to another universities in Kazakhstan.
Thank you. More than clear.
Thanks a lot, Sultanat. It was, and we're gonna have the next presenter with the paper number 185. which is Tanavan Kurjanov, and the title of the topic is Diagnosis using Electrocardiogram, data hearing from the Astana IT University. And you may begin your presentation.
Hi, how do I do the presentation?
Открыть, да?
Да, когда вы вам вы можете клики взять и бюджет поставить.
Здравствуйте.
Please speak Nazarova Saida. Sorry if I mispronounced your name. You'll be the next presenter with the paper with ID number 45.
Okay, thank
Thanks. You should come here and sit in place and turn on your mic. Turn on the microphone and to push button and start. Yeah.
So hello everyone, my name is Nero. I've come from Astana University, and my research title is comparative analysis of neural network architectures for cardiovascular disease diagnosis using electrocardiogram data. So in summary, first of all, you can see the abstract of my work in my slide. I'll discuss you the elements. For now, in summary, so basically what we've done is compared different architectures of neural networks, some older ones, some newer version ones, and to all the other representations. So why does this research matter? First of all, cardiovascular diseases, or CVDs for short, are the top one global killer, which causes approximately 18 million deaths annually, which means that almost 1/3 of all mortalities come from the cardiovascular diseases. It strongly affects low middle income countries, which were 80% of CVD-related deaths due to limited healthcare access. And it's important to early and accurate diagnosis, so we can prevent fatalities and improve quality of life. And I have chosen ACGs because they are non-invasive and largely available, making them just perfect for early detection. First, I'll discuss with you the CNN-based approach, which has been with us for a while. The CNNs are very good at learning spatial features. For example, with the ECGs from multi-lead signals. And CNNs don't require many processing. Some researchers have said that CNNs achieve cardiologist level accuracy in anatomy detection. And some people implemented explainable CNNs, which use heat maps to highlight important ECG regions. CNNs are well suited for real-time wearable patients due to their speed. They're quite fast and accurate diagnosis. Next, I'll be discussing multi-layers, long or short. MOPs are quite simple and yet adaptable feedback networks that use the propagation for training. One flow, as they require available data for training, but most of them do. And their strong type is that they can approximate any complex relationship with one or two hidden layers. And another one strong side is that they're extremely fast and don't require a lot of computational cost, which makes it perfect for wearable devices and weak hardware. And moving to recurrent and hybrid models, the recurrent models are RNNs, especially LSTM, are temporal dependencies in with this kind of dependencies and CNG sequences and hybrid models like CRT-net, because they combine CNNs, RNNs, and the transfer models. From CNNs, they extract spatial features. They use PIGRU for sequence patterns, which is an RNN, and the transformer all to encode the global context. This ensures high robustness and general stability across spatial types. It's perfect for monitoring long-term new detection, and what requires a lot of computation costs. Transformer-based models use some attention to capture longer range patterns. They excel in grasping the global context, like McArticle and fraction detection, and they may outperform CNNs and RNNs in multi-class classification, but their computational cost is also very, very high. So, from the studies, I have gathered the benchmarks that have been used to evaluate those models. And as we can see from the tables, it has been reported that MOP scored very good accuracy, 99.3, and amazing F1 score of 99.83, and CNN being a strong baseline, scored also pretty scores 96.1. And the OSTMs for sequence modeling scored 27, and the transformers with very good F1 score, but lower precision and accuracy. In the studies, it mentioned that the datasets used for MIT BIH dataset for CRT-net hybrid model, which outperformed other models in terms of accuracy, with accuracy being 99.6%. And in summary, MOP, I forgot to mention the first models. They used self-collected package data of 186 records that we got from global hospital, and from that we can conclude that MOP excels on that dataset. However, we can't really see the true difference because they use different datasets. So that's the flaw I wanted to fix by making the experimental analysis. I used the MIT HRP dataset, which included 14 recordings with 5 diagnostic assets, and all of the recordings were sent to 187 point ECG sequences. For test setup, I split data to 84 trained and for validation, then for test, trained each model for 30 box. And for optimizer, I used data with learner rate of 1/1000, and was used across. So, and from that results, we can see that MOP being very simple, really took not much of training time, but only 42 seconds, and restored us with great accuracy of almost 99%. CNN being also quite fast, and giving us good results, still give less performance, and SCRT.net showed the most outstanding result with error margin of less than 1%, while transformers and OSTMs have taken a lot of time, or OSTM took a lot of time, with a little bit smaller accuracy result, and transformer we goes faster, but the result was worse. So the key takeaway from that is that MOP, however simple it is, and performed just great with 42 seconds of training time and 98.93 accuracy, which is very efficient and effective. And CNN's strong extracts the spatial features performed 97.8, but suffered with long-term dependencies. While the scale was very high cost and moderate returns, and transformers just underperformed standalone because may need further optimizations. And Sentinel.net best performer 99.84% hyper design proved itself superior to others in future research. Might be great to optimize MOPs with attention optimization to make security even better. And it would be also great to implement this lightweight CRT net, which will take less time to train and to process the data and maintain its high output. Also, since transformer underperformed, it mostly means that should be designed for specific ECG usage. Yes. No. And from that, we can basically conclude that the hybrid Sentinel.net is best for precision critical clinical diagnosis like large hospitals if analysis time is not important and the movies are just perfect for resource constrained use. And that's it from my side. I'm happy to answer any questions if you have any.
Thanks a lot. Sorry, mispronounced your name. So thanks a lot for your research, and me myself as a researcher within the extended reality, I have developed a project which has studied cardiovascular disease, but from the perspective of virtual reality and development of some training set for the surgeries. I know that the problem is really relevant, and actually the CVDs are the main cause of all the deaths of human population all over the world, independently on the income of the country and your status. So are not secured with anything to avoid the CVD effect on your health. And your research is really interesting, and I'm really glad that you are have picked this one. And actually, you have described in general the model of your study. But could you please tell me, is there any specific features of the ECG which affect the status of health or development of certain disease more than any other feature? For example, there maybe heart rate affect it more, or maybe the other feature that may affect the development of disease too. Thanks.
Yeah, sure. So when scanning ECGs, it's important to mention that a normal ECG has a certain pattern to it. So the lines usually look the same if present away. However, sometimes small abnormalities can be seen on ECGs, and that gives away the potential for cardiovascular disease. So that's what we are looking at basically. So sometimes lines just go. You may, I presume you have seen the ECG reports in your life, so I'm pretty sure you know what I'm talking about. Sometimes those lines fall down or too high than normal, and that's what we're looking for when diagnosing CVDs.
Thanks a lot, everyone. A really nice report. And our next presenter with the paper ID number 45. The title is The Effective Method of Digital Processing of Systems Media Resource of Business Entities. And here I'm happy to announce our colleague from the Uzbekistan, Saidat Nazar. I'm sorry if the pronounce is wrong. You may begin, and could you please share your presentation? And you may start. Thanks.
Hello, could you hear me?
Плохо слышно вас.
hear you, but unfortunately the volume is too low. Could you please turn it a bit up?
Меня слышно?
Вас тихо слышно. Можете немножко погромче сделать?
Я максимально сделала. Сейчас постараюсь еще погромче говорить.
Хорошо.
Демонстрацию экрана мне самой включить?
У нас нет.
Вам так удобнее будет переключать. Но если хотите, мы можем сами включить.
У нас ее нет презентации.
Вы
Давайте тогда да, дайте, пожалуйста, организацию.
Доступ есть у вас? Вы можете.
Да, все, я подключаю. Угу.
Спасибо.
Спасибо. Здравствуйте, видно?
Да, видно, можете увеличить это. Слайд сначала.
Видно?
Да, все видно.
Okay. Good afternoon, dear organization, the participants of this conference. Our research article, it is called Effective Method of Digital Processing of System and Media Resource and Business Agilities. The main authors of this research paper is Beknazar Said, Abdullah Zafarbek, Abdullah Safibullah, and Abdullah Al-Assad. The main research goal, it is a primary of the research to develop or justify an effective method for digital processing of media resources within the multimedia system, ensuring the high performance quality presentation and availability during the transformation, storage, and the playback of digital content. The main objectives of this research is to analyze existing methods of digital media resources, identify the key issues related to the efficient and quality multimedia data processing, develop the algorithmical model concerning the features of the model media formats in the storage system, propose the architecture for the integrated system for the digital processing of media resources, and evaluate the efficiency of proposing the method using the case matrix. The main problem statement you can see in this slide, this is a exponential growth of multimedia data and the resource video, audio, graphics, and we are must to use traditional methods, often the first to provide the reference level to adaptability, scalability, and optimal balance between the quality and the processing speeds. The scientific novelty and the hybrid method for the media processing of the processes, the integration, adaptive filtering, and the stream analysis, and the structural compression basis, and the dynamic profile of the media resources. The next novelty is the combining the intelligent process and mechanism with the optimization, the according the media data format, and the use of the context, resulting in the increased efficiency of the report. The main what we are use and we are prepared, it is a hybrid method of the digital process of the media resources. This hybrid method consists of the 4 steps. The first step is the adaptive filtering. Adaptive filtering allocated the local content features. It is the spectral and the temporal noise estimation to identify areas with the high improbability and the motion. The secondly, we are use the contents-aware filters such as the anisotropy, diffusion, the lattice filters. And the third, we are real-time parameters adjustments using the feedback from the streams of the analysis the model on the preserve the age, textures, and the color identifiers. The second step of our algorithm, it is a stream analysis. The stream analyzes the following screens. It includes the first of all, the temporal occurrences detection. These steps, it is identified the reducences and the patterns across the video frames of the audio samples. The second step, it is the flow segmentation. As you know, this step divided the media streams into the logical segments.
And thirdly, there must resource-aware profiling. It is monitoring the CPA memory and in the real time. The third model of our algorithm, it is a structural compression based dependable graphs model to analyze and the encoding data. It is include the hierarchical encoding, contextual model, and the pattern recognition. All of these steps, it is allows the lossless or near lossless compression. And finished with mass dynamic profile engine. Dynamic profile engine monitors the free coefficients. It is a media content characters, the system load metrics, and the user-defined quality of the service. In this slide, you can see the main structure of our hybrid method, which is consists of the four basic models. It is dynamic profiling engine, adaptive filtering, next the stream analysis, and the structural compression of the image and the media resources. And all of this is control of signals and the compression media data. In this slide, you can see as the mathematical model were give in our research paper. The main methodology we are using our research paper, it is a wavelet transport technical, the structural analysis, the simulation modeling, the machine learning algorithms, and the computations and modeling. In this slide, you can see the main results and the discussion. All of the we're using our methods. We are to get 13 savings the compilation resources, the 20% improvement in the reconstruction quality, and the reduced latency in the data transmission, the real-time streaming environments. Okay, this is all. Thank you for your attention. If you have any question.
Thanks a lot for your presentation. It was really interesting. And any question from the audience? No question? Okay, I do have a question for you. Have you introduced your developed system into any like real-time practical use, or is it like for now it's only theoretical one?
This is, we are preparing the main model for the processing the image. We are using the multimedia information system. The main problem of this image, it is we are must processing in real time the video and audio. It is the most problem of our research.
Right. Thanks a lot for your presentation. The report was really nice. And I think that this is the end of the first part of our section number 2. And now we're going to have a coffee break for all audience here who is in physical, in-person appearance here, presence here. So, and we're going to continue our section just in 20 minutes. At 4:20 by the Astana time. So thank you for all the reports and presentation, dear colleagues, and wish you good luck for your future work on your research. Thanks. Dear colleagues, we have to continue our section number 2, IT in education research. And our next presenter is Volkan Yurdaeva with the paper titled Using Machine Learning for the Prediction and Treatment of Mental Health Conditions. So Volkan, please share your presentation and you may begin. And dear colleagues, please remember that the time limit is 10 minutes, 7 for the presentation itself and 3 minutes for the questions. Thanks.
Hello, can you hear me?
Yes, we do. Thanks.
Can you see me now?
Yeah, we do.
So hello everyone, I'm Tulita Vatulkan from Astana IT University, and today I'm going to discuss how machine learning can revolutionize the way we diagnose and treat mental health conditions, moving us from reactive care to proactive interventions. So let's start with the introduction. Mental health disorders affect over 13% of the global population, with economic cost projected to exceed $6 trillion by 2030. Yet our existing toolkit is clinical interviews and self-reported scales like PHQ-9 relies heavily on subjective judgment, often resulting in delayed or inaccurate diagnosis, even if we are using the DSM-5 or MKB-11 or 10. Our study pursues 4 goals. The first one is quantify how various machine learning algorithms perform on mental health prediction tasks. The second one is demonstrate the added value of combining heterogeneous data sources. And the third one is we want to build a framework for personalized treatment planning. And of course, to address ethical challenges around privacy and algorithmic fairness. Unlike previous work that focuses on a single modality, we integrate electronic health records, MRI, functional MRI, wearable device metrics, and social media signals into one unified pipeline. So talking about literature review, current diagnosis treatment practices, we have clinical interviews, self-reported questionnaires, and standardized tools, and all of them have their strengths and weaknesses. And we wanted to create a model that would be better than all of it. About analysis, a systematic review of 40 researchers study conducted over the past 20 years was performed, and here you can see the results of it. This is the best papers I highlighted. You can see the sample sizes and different data types and algorithms we used. So I tried to combine it in my research and use some of the data sets too. Key findings by the literature review, the best 2 articles that showed using the different algorithms. The social media dataset achieved the impressive accuracy, 98% using regression-based models, LR and RIDGE. And the hospital dataset demonstrated the strong performance with tree-based classifiers, reaching accuracy of 89% for random forest and 87.8% for G48. And deep learning models, specifically long-term memory, performed exceptionally well on sequential data, achieving accuracy on 80%, while MLP reached 77.8%. So talking about the methodology, we collected AHR for demographic and clinical baselines and neuroimaging biomarkers via structured and functional MRI, wearable sessions capturing sleep patterns, activity levels, heart rate, and so on. And the social media data is text image analysis to flag early behavior changes and detect them. And for tabular data, we employed random forest, SVM, and CNN for the imaging, and transform-based NLP for handling the texts. So here also you can see the structure of it. So data sources to data present, and then ML approaches, evaluation to clinical applications, and also considering the ethical considerations. Also about ethical consideration, considerations, of course, we strictly adhere to GDPR and HIPAA. All data are anonymized and access is role-based. The counter biased. We also balance training models with a 50% males group and women's group. We ensure we're working on sharp alignment to allow the clinicians to see which features drove each prediction. So yeah. About the insights, our multimodal achieved 93% diagnosis accuracy, outperforming single sources baseline by 12%. And CNN analysis of MRI data alone reached 89%, while transform-based sentimental analysis of social media hit 85%. Crucially, the ensemble pipeline reduces false negatives by 30%, enabling earlier interventions and potentially better outcomes. So yeah, I would say that using the multimodal models is better, and I'll keep working on it to do it better. And yeah, thank you for your attention. So it's showing the great results nowadays, but using more multimodal now in our research now we're using the MRI and the questionnaires, but adding the more features would add more accuracy to our results. Yeah. Thank you for your attention. I think that's all. And thank you for the ability to present my presentation and talk about my research.
Welcome. Thanks a lot for your presentation and your report. The topic is really relevant and interesting, and as I know, especially after the COVID epidemic in 2019, the amount and the percentage of the spreadness of the mental health problems increased really drastically. So it's really interesting that you have chosen this topic, and I think that it's really important for our society to check not only the physical health but also the mental one, and it's really great, and we really appreciate your research. And maybe some people from the audience have a question for Tolkien. Actually, I do have a question, and the question is, how do you see the integration of your idea into real life? So in what form do you see the application, or maybe you want to highlight just in the form of analysis the problems and directions where the people have struggled more, or you want to really develop certain maybe a mobile application or any other stuff that help people to reduce the stress or maybe to improve the mental condition? And yeah, that is the question. In what form you want to integrate your application?
Thank you for your question. I would say I want both of them, but first of all, I want to concentrate on several mental health disorders. For example, now I'm focusing on bipolar first and the second, and borderline personality disorder, because it's one of the hardest to evaluate the disorders. And yes, wearable devices. And first of all, I'm dividing my research by parts. So the first one is the prediction. So I want to predict and help to get the real diagnosed. So they get they're really diagnosed, and they can monitor their medicals too, because how they're affecting their brain in a real time. It's like using the MRI, and also for the bipolar disorder is to predict the mood swings that we have there. So first of all, first part is about this one, and second of all, yeah, it's the wearable devices or support applications that can help them to first of all I would say how to say it. like see how their diseases is going, if it's helping, if their medication is helping or not, or what's going on in real life, in real time with their brain and with their body and mental health in general.
Great, wish you luck for research and future works, and thanks a lot again for your report. It was really nice. Thank you.
Thank you.
And for now, our next presenter is Asmali Osman with the theme Designing an Adaptive Educational Platform for UNT Preparation and Machine Learning-Based Approach. So, and I'd like to ask Dursun Kantursono to be prepared because you'll be the next presenter.
So, hello everyone, my name is Aslan Osman, and I'm going to present Designing an Adaptive Education Platform for UNT Preparation, Machine Learning-Based Approach. So here is our outline, introduction, research questions, challenges, methodology, results, system design, conclusion. So let's start. The Unified National Test or UNT is a crucial standardized exam in Kazakhstan for high schools graduation and university admission. So it's important for us because based on the results of UNT, student will be decided to get scholarship or not. And so challenges are linked to personalized feedback, high reliance on costly private tutoring, and educational disparities between urban and rural students. And the goal is designing an adaptive ML-based platform to close this gap and also to identify weak and strong topics. And research questions are: how can ML create personalized, real-time learning for UNT Prep? Can such platforms improve engagement, performance, and inequity? And our object is to build a system that recommends study plans based on student performance data. And so challenges are rural access issues. So in Kazakhstan, students who live in rural areas, they have problems with internet and device gaps. For example, in one family can live 7-9 persons and they have only 2-3 devices. And next problem is low-income families. To study UNT, to prepare UNT, students need extra specialized books, which contains only questions for one subject, and additional schools, tutorings, which all of them cost money. And for low-income families, this is a big problem. And language diversity, UNT has Kazakh, Russian, and English, and our platform must support all. And low trust in ML, I will talk about this later. For now, I want to say that this can be solved by explainable recommendation logic. So for methodology, we use quantitative research using cross-sectional survey, and it was online questionnaire distributed by Telegram channels, chats for first-year students of Astana IT University. And questions were closed-end and open-end questions, and questionnaire was voluntary, anonymous with informed consent. And in methodology also includes the design of prototype. So the results, in our survey participated 109 students, they all recent UNT takers, and 93% of them use digital tools, and adaptive learning rated as very important. And based on the results, students want topic-specific practice, gamification, real-time analytics, study scheduling tools. And main problems are time management, inconsistent internet in rural areas, lack of transparency in ML decisions. And trust in ML-based recommendations for model is 3.2 from 5. As I mentioned before, this is low trust in ML part, and this can be solved, as I mentioned before, by explainable recommendation logic. Here we can see the graphs. So in left top corner, we can see the pie chart. In red, 63% of the students studied from 5 to 10 hours, and 23.9 students studied more than 10 hours, which means that the importance of the UNT. And near of this pie chart, we can see the chart with the main challenges, as I mentioned before: lack of personalized guidance, limited access, time management issues, and so on. And below the pie chart, on the left side middle, we can see the bar chart where students choose from 1 to 5 machine learning based feedback would help when they start this topic. And mostly half of students choose for that. It means that students believe that machine learning based could help, but below we can see that 42% of students moderately trust for the machine learning algorithms. And so this is low trust level, and we need to explain our recommendation why we're recommending something for them. And middle right side, we can see that 93% of the students use digital tools or online platforms for preparing LinkedIn. And below them, we can see the problems. It's most important for preparation. So nextly, let's take me as student who's going to pass UNT. So when I will enter my platform, I will choose math informatics because I'm going to pass UNT for IT. And next step, I'm going to pass, try UNT, and then based on the result, ML platform will analyze. And after that, I'm going to recommendations. So I'm going to the dashboard part where I will choose the subject. For example, let's take math. In math, I have 3 topics. First topic is algebra, where I have 10 questions and I have answered 7 of them incorrect. And next is trigonometry, and where from 7 I have answered correct 4. And third topic is probability, where I answered all of them correct, 5 questions. And when I will in dashboard click math, algebra and trigonometry will be highlighted that I need to study that topics more because I have problems with them. And for future development, our platform will give personalized study plan, recommendation to study, watch lessons, target mini quizzes, and bookmark for the lesson. And this is going to by collaboration with the other companies. For example, we have company which is preparing for UT, let's say, to study. This collaboration will be win-win because by my platform, students will know their weak topics, and by the company's material, they will study them. So to sum up my presentation, I want to say that students are now ready for the smart learning tools, and our ML approach can reduce educational inequality. And we believe that our platform can be served as a foundation for the ML-based studies, ML-based course in national education system, and especially in personalized education. So thank you for your attention. That's all. If you have questions, feel free to ask.
Thanks a lot, Asmali. And maybe some of the audience, someone have a question, or maybe those who are connected online. If you have any question, you may ask it now. And actually, I have a question for you, Asmali. As I got, you have conducted like the first stage of your research, just like the data analysis. You have detected and defined what problem what problem exists for now for students, for like what to say, the middle school students who have to prepare to the UAT test. And by your opinion, what features have to be analyzed and put within the machine learning model in order to improve the performance of the students using your platform?
So as I mentioned before, in final part, it will be based on the accuracy of the correct answers and difficulty of the question, and every time which user spend on question. This will be the main variables inputs for the getting result.
Okay. And are you planning to introduce some like gamification tool for the education process to make the study within your platform more interactive and more gamified, interesting for the final user?
Yeah, I thought about this. I'm planning to do gamification if I will have some free times, because this system is difficult to do, and so gamification for me is in second plan.
Okay, got it. Thanks a lot. Wish you luck for your project and hope that you're going to implement it, and it will be a great tool for students who are preparing for this test, because it's really interesting and important that you have mentioned the rural areas where people don't have the good level of internet connection, and also some devices like laptops, smartphones, which can provide like different approaches for the preparation for the UNC. So thanks a lot. I hope that you're going to have a great project in the future. Thank you. And our next presenter is the authors of the paper number 160, Krasnov and Tursunov. And the title of the paper is Comparative Analysis of Recommendation Algorithms, Collaborative, Content-Based, and Hybrid Approaches. So, Tursunov, you may begin your presentation. And our
see my presentation?
is Yes, will be the next one.
Вас плохо слышно, можно громче?
Так, теперь слышно?
Да.
Okay, so hello everyone. My name is Tursunov, and I'm representing Astana IIT University. So my paper is comparative analysis of recommendation algorithms, collaborative, content-based, and the hybrid approach. Why is this research important? Because with the growth of digital platforms like shopping, streaming, and the learning, recommendation systems play a critical role in helping users find what they need. There is, however, we face several challenges, like there is too much information available, and the user expects not just relevant, but also novel and diverse content. And the individual algorithms like collaborative or content-based filtering have limitation, such as data sparsity and the lack of diversity. So our work aims to more adaptive solution. The main goal of the research is compare the performance of the three different types of recommendation algorithms. So we used a popular movie lens dataset to evaluate which of these models provides the most accurate and personalized recommendation. And about the practical significance, they can help developers and the business build smarter and more scalable recommendation systems in industries like e-commerce, online educations, and the digital entertainment. So in this study, we specifically evaluated the SVD++ algorithm for collaborative filtering and the TF-IDF for content-based filtering, and a hybrid approach which is combining the two algorithms. So about the collaborative filtering, the collaborative filtering is based on the assumption that users with similar preferences will rate items similarly. So we use that SVD++ algorithm, which is a refined version of traditional SVD. It includes both like explicit feedback, such as user ratings, and the implicit feedback like clicks or views without ratings. Okay, so how SVD++ works? It's actually factorize the user item matrix into latent features, and these features represent each user's preferences and each item's characteristics. And during the training, these vectors are optimized to predict the rating accurately. So the advantages include the better handling of sparse datasets and the ability to capture subtle user behavior, and improved generalization through reduced overfitting, and the content-based filtering is this approach uses the item features like genres or tags to build a user profile. Okay, and we used TF IDF algorithms for content-based filtering, which is convert movie genres and text into numerical form. TF measures how often a genre or tag appears in a movie. For example, if actions appears frequently in a movie, its TF will be high. And the IDF reduces the weight of very common terms like drama that appear in most movies, like that. And the final TF-IDF score combines both the TF and IDF to emphasize unique and informative features for each item. And about the hybrid model recommendation model, it's the hybrid model combines the best of both filtering. We used SVD++ to capture user behavior, and TF-IDF for to understand item content. When combine both scores using a weighted average, like hybrid score, it's to allow us to fine-tune how much influence each model has. And the result of that system was more accurate, more diverse, and less prone to cold start issues. About the algorithm workflow is as you can see, we begin with data pre-processing, and then move on to feature extraction, then run each model separately, and finally evaluate results using standardized metrics. About the results we used here, there are 3 models, which is run by 10 folks, and we used performance metrics like precision, recall, F1 score, accuracy. So as you can see here, hybrid model had the best overall performance with F1 score 0.9186, and the RMSE is here 0.3233, and that's all about the model trainings. Hybrid model is achieved at the highest validation accuracy, as you can see, handle the lowest loss. Так. Collaborative filtering reached the 0.85 and the content-based filtering ended with 0.74. So about the if we say about the conclusion, our hybrid recommendation model outperformed the standard collaborative and the content-based models. It addressed issues like that data sparsity and the cold starts and the lack of diversity, and this makes it an ideal solution for real-world application that require both personalization and this scalability. So thank you for attention. If you have a question, I can answer.
Thanks a lot, Tursun Khan, for your report. It was really nice, and I think that your system would be great for like any e-commerce or like almost any interactive system that have like requirement system, even like some e-learning sources as Coursera or like any Grammarly, where the user can get certain suggestion for the course or any goods for shopping and all this stuff. And actually, I would have a question for you, Tursun Khan. Are you with us?
Thank you.
Could you please turn on your for the until the end of your answer?
I couldn't hear. Can you repeat, please?
Could you please turn on your cam, because now we cannot see you.
Turn on camera.
Yeah.
Yeah.
So the question is, how can user feedback some improvements on the suggestion of your system? So, for example, if I'm interested in buying some goods for the fashion, how can I improve your system? How should I interact with it? Thanks. Or you haven't mentioned.
About that, I was thinking about the to include the deep learning systems, like can
From the orientation, yeah.
about them.
Mm-hmm.
Yeah.
And also I have a question, is there any difference between the profile of the system where you install your recommendation average model? So for example, is it e-commerce or is it some like educational tool? Will be like any difference in model learning, model education?
But actually, it's it not depends on the data sets if you present.
So thanks a lot, Tursun Khan. Wish you luck for your future work and hope that your presentation will be as great as you have shown it.
Can I ask a question?
Yeah, sure.
Yeah, actually, I see that there is some machine learning algorithms are used for content-based or collaborative based filterings, but I did not understand the reason. Why did you choose these certain algorithms? Actually, there are many algorithms in both way actually. So there, I see that, for example, SVD is used there, right? But why you did not choose, for example, random forest or the other algorithms from the
I made
collaborative filtering and also content-based like this one?
So I evaluated the algorithms from the benchmark, and the best RMSE it showed the SVD++ algorithm. So I decided to choose this algorithm.
So as I understood that you run these models first, and then from there you are showing only the results from SVD, right?
Yeah.
Oh, okay, I got it. Actually, yeah, you could include it in the presentation so that what was your kind of literature review actually you have. Okay, thank you.
And our next presenter is actually Yes. Please welcome, and the title of your paper is Enhancing IoT Education with an Educational Robot, a case study on hands-on learning. And could you please share your presentation? Yeah, great. Thanks.
Okay, good day, dear colleagues, also the participants. Okay, I am Zhumanias Mohammad Nabih. I'm from the SD University, Kashgar in Kazakhstan. I'm going to present my work about the use of the educational robots in the IoT course, and also about I'm going to discuss about my case study, actually what we did with the experiments with this one. And in next minutes, I will talk about the background of my work, and also what was the methodology when I was checking and making kind of the experiments and my experimental setup, and also my tool that I have used there, and also some results that I got from this work. Okay, the first thing it is about, as we know that when teaching the Internet of Things, it has many domains. Actually, it has kind of the the electronics, networking, data collection, and also the cybersecurity. In this case, mostly in the universities, they use the simulation tools like a Packet Tracer or the Tinkercad, and also other educational kits are used mostly. But our hypothesis is that what if students use the educational robots? Maybe it could be kind of the main engaging, and it could be the interesting to the students. Okay. So that is the practical tool that we are going to use. And also the other thing, it is the many educational robots, they have a higher cost. Okay, so that is actually from this table also we can see that there we have compared different educational kits and also the educational robots which could be used in the IoT classes for learning the Internet of Things. And from there we can see that they have very high cost. And what if they have this one? It is Hydra, it is called. It has 35 euros, which is less than the ours, but the others, they have the higher cost. So based on this kind of the literature review, actually, we have created educational robot, the developed educational robot. It's called IoT Explorer Robot. And then our aim was to compare, to test this educational robot during the IoT class. Okay. So then our methodology, it is here we first created our educational, we have defined the hardware components, and then we have also chosen what would be the printed circuit board, what could be the microcontroller or development board for this educational robot. And then we stated the indicated activities based on this robot, like getting based on their hardwares and softwares, what we can do it. And then we have we evaluated this work. Okay. So the IoT Explorer, what it stands for, the educational robot for exploring the Internet of Things. It has the open design and the open source. And we have discussed about this work. We have explained this work in our previous works. Actually, you can go by this source, to find more about this educational robot. And from there also you can see how we have continuously improved this educational robot from cardboard to kind of the sustainable chassis it has, the PCB board, and we have also changed it, worked with different research. We have done with different research with the different types of development boards. Okay, so then actually it is about some kind of built-in electronic components. They have kind of wireless connection. It has built-in Bluetooth low energy. It has also the IMU sensor also could be found in this board. Okay, and the approximate cost for this education robot, it was 55 euros, which is much less than this ones actually that we have shown in this table. About the experimental setup, then once we have developed this robot, then we try to make an experiment in the Internet of Things course. The course is called the Introduction to IoT. It is taught to the computer science program of the bachelor students at the university, and 33 students were enrolled to this class, and then we did not divide into groups, but actually then we had two groups. In one group enrolled 20 students, in another group there was 13 students. Okay, so we have, for one group, we have used the traditional method, like you used Arduino Kit and also Packet Tracer. And for the experimental group, where we are using our educational robot, there are enrolled 20 students. Okay, so then we have designed 10 activities, and also the complexity of these activities, they also grow while students also doing kind of the different activities. Okay, so they progress from the basic controlling of the robot to the cloud control. It means that in the 9 stands activities, they will be able to create kind of the electronics, connect with the network, and get the data from using the sensors, and then store this data in the cloud and make some kind of the data analytics, the analysis for that one. Okay, so then once we have it, actually these are some focus areas of this curriculum, like engineering skills. They should have they will also gain the algorithmic programming skills with the robot, and also networking and technology, and also data analyze skills they will pursue doing this kind of the activities. And when these are some activities where they cover different skills, and then the results show that we have given the project, and the project, it is same for all students. Okay, it is all for students. And then what do? It is and we did not ask them even to use this educational robot. They can use any kind of educational kit, any kind of the tool or the technology. So then while they were doing this kind of the project, the experimental groups, the average score, it was almost 64%, and for control group it was almost 53.4 points. It is the average score, and from there we can see that using these kind of the educational robots, they will increase the creativity and engagement of the students in this IT based courses. Okay, and also we have also taken some kind of the quantitative, the qualitative feedback. Actually, 88% of the students, they replied that they found the robot enjoyable for their class. Okay, so then as a conclusion, we can say that this kind of the robot, they can improve the hands-on IoT education, and also they increase the student engagement, and they also pursue the interests from such kind of the class. Okay, as a future work, we can extend it using the AI, edge computing, and also we can extend this kind of works to different courses. Actually, so there they can use this kind of the educational robots for different computer science-based courses. Okay, so here are some works which are related to these ones. Actually, in the first one, we have discussed about how we can use the education robots in different courses, not only the IoT, but also the AI, for example, machine learning, data science, or even algorithms course or programming courses. And then another two works, they are more about the development of this robot, like hardware components, their softwares, and different things. Okay, that's it. Thank you. If you have any questions, you are welcome.
Thanks a lot, Yes, it was really great and interesting report, and I'd like to admit that it's really nice that you have implemented not only the research in terms of like theory, but you have also implemented the real hardware project, and you have conducted the research with like focus group and with like the other one who's experienced the traditional way and average for the education of computer science. It's really nice, and thank you for your report, and hope your like research gonna expand, and as you have described like the future work with introduction of AI and ML. And could you please tell me how do you see this implementation? In what terms? Are you planning to create another kit for robotics that will have like will work with AI and ML, for example, maybe to define the obstacles and maybe connect them to several groups, for example, or so in what way you want to implement it?
Yeah, thank you. So was it kind of question?
Yes, sure. How you're planning to integrate AI and ML within your project? Will it be expanded as well? Will the kit expand as well within integration of AI and ML, or you just want to add some new models, for example, to maybe to sort the legal sets, or maybe to sort some stuff using your already created set, the kit that you have developed.
Thank you. Thank you for clarification. Okay, so actually, our here, if you look at to this PCB board, there we are using the development board. It's called Arduino Nano IoT 33. Okay, so actually the Arduino, it has a bunch types of the boards. Okay, and also, for example, it has a Arduino Nano RP40 2040. Actually, Raspberry Pi also has such kind of the board. Actually, for using this kind of boards, we can apply the tiny machine learning algorithms there. Okay, so there actually in our another course, which is called the IoT Data Management and Analytics, there we use the Raspberry Pi Pico board, which is also based on the RP2040 microcontroller. Actually, from there, what students can do it is they collect the data using the sensors that are available in this board, and then once they have enough data, they can create their own machine learning models. So then there are many types of it is tiny machine learning, it is called. So we can first build kind of the machine learning or AI model, and then we will just how we can say shrink this model using different case. It is called from the scikit-learn. Actually, also they have, and another thing is Edge Impulse. If you go to edgeimpulse.com, there is a website where we can just run your machine learning model, and then we can shorten this, make a small algorithms, and then we can just convert it to the tiny machine learning algorithm and then send it to this board. Actually, using this one, it is also possible. So that's why while we were kind of designing this kind of PCB board, we also consider this thing, how we can use also for machine learning or edge computing. So in such case, this kind of robot could be used for different cases, for different courses. Also, for example, for computer vision, if you connect a camera, in this case, we can get data. So you see, in this case, using this kind of robots, we are getting the information from the environment by their sensors, and then we can integrate it to Zera, so we can see their real world applications, kind of using their actuators. In such case, it would be more engaging, as we did in this course as well.
It's really nice. And also another question. If students work in group or it was like individual project, so you have highlighted that you have in total 33 students and 20 of them worked with the kit. And did they were divided into groups, or they have like individual kit for each one?
So actually, it is there in the control group they use the Arduino kit. It has kit means it has the another without this kind of the robotic shape. Like in this case, they used some kind of Arduino Uno board, and some activities were based on the packet tracer. It has kind of simulation tool. It was the traditional tool which we used in previous years. And this year, actually, we had a kind of new tool, and then we just tested it with these two groups with them. But actually, yeah, there is kind of the problem with this kind of the experiment because we don't have the same number of the students. It is one problem, but we did not. Actually, based on the schedule of their schedule, we could not make them the group number of the students the same. So that's why it was one problem. But still from there, I think we got pretty good result.
Definitely, because it's really interesting research, and hope you're going to expand it and like implement some new projects and also share the result with us next year maybe or even sooner. Thanks a lot, Jim. Yes, wish you luck. Thank you.
Okay, thank you too.
And our next presenter is, I think, Martina Masurova. Is she with us? Unfortunately, I cannot see her. And then we have Absalam Wanash, and the paper ID is 304. And the title of the paper is Algorithm for Using Artificial Intelligence in Predicting Fire Danger in the Selene Forest in Kazakhstan. So, Absalam, please, if you are connected, could you turn on the camera and also share the presentation with us?
Yeah, sure. 1 second.
Class.
Can you hear me? Hello?
Yeah, everything's
Good evening, everyone. Today I'm going to talk about the algorithms.
Sorry.
Yes.
Turn on your camera for us.
Is it good now?
Not yet, unfortunately. Yeah, thanks.
Good evening, everyone. Today I'm gonna talk about the algorithms. So my team is Algorithm for Using Artificial Intelligence in Predicting the Forecast Dangers. And today my team is based on the example with a forest fire, which was in Semey in 2023. So forest fires pose a serious threat to biodiversity systems, national economies, and public safety. Effective fire hazard management requires not only accurate forecasting, but also the consideration of regional specific factors, particularly in ecologically vulnerable forest zones. In recent years, a growing body of research has explored the application of artificial intelligence, AI methods to wildfire prediction, offering promising opportunities for automation and improved model accuracy. So the objective of this study is to design and implement a multi-layered AI-based algorithm specifically adapted to the climatic and geobotanical characteristics of Eastern Kazakhstan. The proposed system incorporates real-time sensor data and simulation-based modeling to enhance predictive accuracy over traditional indices and to address the identified gaps in the current body of international literature. So, for example, in 2023, there was a huge forest fire which occurred in Semey, Kazakhstan. The forests of Semey in Kazakhstan play a critical role in enabling productive analytics within artificial intelligence systems aimed at safeguarding these unique ecosystems. So artificial intelligence offers powerful capabilities for analyzing complex, large-scale datasets and generating accurate predictive insights. Utilize learning algorithms and predictive models capable of identifying nonlinear patterns within data. So we're gonna move on to the practical section. We're gonna talk about the formulas we created and used based on meteorological data we took from the forest fires, which was in here is mathematical model for the fire probability. So this formula where T is temperature, H is humidity, V is wind speed, and we took the standard pressure, and the alpha is regional fire sensitivity for Semey in our case. So the classification of fire risk levels. The following steps outline the implementation of artificial intelligence for predicting wildfire hazards. So the data collection is deployment of meteorological stations and environmental sensors within forest zones to ensure continuous monitoring of atmospheric and ecological parameters. Data processing and analysis. So the application of machine learning techniques to pre-process and analyze collected data with the aim of identifying early warning patterns indicative of fire-prone conditions. So here you can see the classification of the different levels of the fire risk. So we get to very low, we get a low probability, moderate, high, very high, and critical. Algorithm for implementing the method of predicting forest fire hazards in Semey, Kazakhstan. Yeah, so here, if you look at this table, the description says that as increase of ambient temperature leads to a higher probability of fire occurrence, decrease in relative humidity elevates fire risk as dry air supposed easier combustion. And wind speed and atmospheric pressure also influence fire probability. Also, their effects are comparatively less significant. Here's a diagram of data processing for predicting and monitoring forest fire hazards. So we get, if you take a look at this diagram, it's a modeling of ground-based research apparatus for predicting forest fire hazards in the Semey region of Kazakhstan. An intelligent control algorithm has been developed by integrating fuzzy logical methods with neural networks learning. The fire detection system utilizes classical fuzzy models, which is Larsen, Mamdani, and Tsukamoto with an emphasis. Here is another diagram. So this is, as I said before, the fuzzy logic output models, data processing model. You can take a look at this diagram. here we have another diagram of the fuzzy control model using the IDFO AMFIS network. So, waterfall diagram of the fuzzy control model. So my research is based on the forecast fires which occurred in Semey. So what was the problem actually? The problem was that the forecast fire, it was huge, it was large, it occurred very fast, and the Ministry of they just wasn't ready to fight against such a huge forecast fire. And so what we did is we took the meteorological data from that forecast fire, and we did we created some formulas, algorithms for the machine learning using AI to predict such forecast fires in the future and to be ready for them, to be able to fight against them. And so let's continue. The complexity of recognizing dynamic weather condition using intelligent recognition methods depends on the type and quantity of sensor data as well as the frequency of environmental monitoring. There we have another formula where N represents sample size characterizing the volume of data collected, and denotes the structure of type input signals. And we have a computational experiment was conducted to determine this dependency for probabilistic recognition methods, such as the bias. This is the second method. This method is known that statistical reliability is determined by the following expression. So we continue next. For the next, we have these graphical displays. So this first display window in MATLAB for the dependence of ignition probability based on temperature. The second one is based on humidity, and we have wind speed one. This one is based on atmospheric pressure data. Yeah. So if you want to talk about results and discussion, modeling performed in the MATLAB environment facilitated the estimation of occurrence probability in the month of June based on hazardous weather indicators associated with the fire risk in the Semey forest region. This study leveraged the capabilities of artificial intelligence for the early prediction of forecast fire hazards by analyzing data collected from specialized instruments designed to monitor forest conditions. The proposed approach provides an effective solution for predictive fire risk assessment. This model utilizes sensor data including temperature, wind speed, atmospheric pressure, as we said before, relative humidity, and thermal imaging also, and the other environment parameters to evaluate probability of the occurrence. In conclusion, we can say that this research prioritizes the clear data source and ethical methods using public data taken from CASGIS-ROMET and NASA. The AI model was built with explainable AI principles, making prediction understandable for better decision-making in fire management overall. The study uses AI techniques like a fuzzy logic for data-driven forecasting. The system offers fast, accurate predictions and real-time monitoring, enhancing awareness of forecast condition, enabling precise resource allocating, early threat detection, and coordinated emergency response. So AI system helps assess fire risk, preserve ecosystems, and strengthens Kazakhstan's ecological security through advanced environmental management. I also want to finish this one talking about the funding.
Thanks a lot for your presentation, your report, and I think that your research is crucially important for the our ecology. As last years, for example, we have lost many forest area, unfortunately, and what's more important that we are losing people who try to save and preserve the forest and our nature. And hope that your research will bring us as much success as possible to integrate it with some government system to prevent the fire. And I have a question for you. Is there any ratio between the nature-based fire cause and human features, human-based causes that affect the appearance of the fire?
Yeah, of course, there is also forest fires. Most of the times occurs from the people, I would say, who are. This might be the people who are like going out for the, let's say, picnic, yes, for the resting, and like after they spend their times, they like don't follow the rules, like the clean after yourself or the finish the fire. What that was the was made for grilling some food, meat, for example. And yeah, also it must be some children who just, walking around and just like having fun, doing some stuff with fire, they just someone who likes to play with fire. Yeah, I would say forest fires most of the time occurs from people rather than the some natural things, natural effects.
Yeah, and also have another question. Is Marie, in what form you're planning to integrate your system, your AI model into like some government? So for those people who have to protect the forest from fire, how will they know about increased possibility of fire start at certain point? Will they get maybe some alarm message, or maybe they will see the real-time map, for example, and where the model will highlight certain areas with a high probability of fire start, or so maybe some other stuff.
Yeah, so the government could use the let's say this. So we can create the machine, which will be a machine which is learned by AI, and this, like, let's say, device, yes, and this device can be attached to, for example, drones, unmanned aerial vehicles. So these drones with this attached device on them, they can be they can monitor in real life, and they can share their display. from real-life monitoring. And this could be the one way which the government could use no, this could be the one way useful.
Thanks for your report. I hope your system and your model will bring us like real secure and nature preserve. So yeah.
Thank you.
And actually, maybe from some people from the audience gonna share the report, but unfortunately, I cannot see people who are online and those who are in the program. And if there none of you gonna present any report, I think that we may complete our section for today. And all of those people who didn't present their report today, we're gonna have our section tomorrow at the same time as given for today in the program of the conference. So you may connect to us online or in person if you are here in Astana for tomorrow. Thanks a lot. Thank you for your attention and have a nice evening. See you tomorrow. Thanks a lot. Мария, ну, они ничего не отвечают, если ничего не отвечают, нужна же Светлана.